Okay, so we are starting trigonometry. So when we're looking at trigonometry, we're looking at right angle triangles specifically. Okay, and in this case, we're always going to have some sort of reference angle, which could be represented by either a letter, which is at the corner of each of the triangles, or it could be represented by a Greek letter. This one here is theta. Okay. But it could be also represented by beta, by alpha, by gamma. Any Greek letter could work. Okay? So in this case, we're just going to start off by identifying the different sides of the triangle because that's extremely important for being able to identify what trig ratio we use. So to identify the hypotenuse, it's always going to be directly across from the right angle, and it is always the longest side of the triangle. So here's the hypotenuse. And then differentiating between the opposite and adjacent sides are a little more difficult. But if you start at the reference angle and you draw a line coming out from it, that's always going to pass through the opposite side. And then the side that is touching the reference angle, that is not the hypotenuse, is the adjacent side. So let's do this one here. Opposite the 90 degrees is the hypotenuse. Opposite the reference angle is the opposite side, and touching the reference angle but not the long hypotenuse is the adjacent. Again, across from the 90 degrees, hypotenuse, across from the reference angle is the opposite, and then attached to the reference angle is the adjacent. Okay? Now knowing that, we can look at these three trig ratios. So it's the sine, cos, and tan ratios that basically allow us to solve for an angle, knowing the relationship between the opposite and the hypotenuse. So sine is going to calculate the angle given a relationship between the opposite and hypotenuse. Cosine is going to help us calculate an angle based on the adjacent and the hypotenuse, and tangent is going to calculate an angle based on the opposite and adjacent. And we remember that as SOHCAHTOA. So we're going to do this problem. We're going to look at the values that are given and trying to determine which trig ratio makes the most sense to do. So we always start off by labeling. So here's my reference angle. The longest side across from the 90 degrees, this is our hypotenuse. And touching the angle here is our adjacent. So if we have adjacent and hypotenuse, I'm going to write this up here again. So, SOHCAHTOA. We're looking for which trig ratio has a relationship between adjacent and hypotenuse, or A and H. And here it is, Ka, A and H. So that is the cosine of something is the adjacent divided by the hypotenuse. So then we can substitute those values in. We don't know the angle, so I leave this as theta. We know the adjacent is 9 and the hypotenuse is 8. And we'll leave it there for now, but in the future we're going to look at being able to solve for that missing angle. Okay. Here we have the reference angle. Across is the opposite side. Attached but touching that 90-degree angle is the adjacent side. So we're looking for a relationship between opposite and adjacent to O and A, which is TOA. So we're looking at tangent of our unknown is the opposite side divided by the adjacent side. Okay. And then next up we have the reference angle. We know the opposite, which is 4, and the hypotenuse, which is 5. So we're looking for a relationship between opposite and hypotenuse, or O and H, which is so. So sine of the angle, which we don't know, is the opposite divided by the hypotenuse. Okay. The last problem I have here is, what if I give you the values and can you draw the triangle? So we need to remember sine is always just the relationship between opposite and hypotenuse. So this number here is really our opposite value. And this value here is really our hypotenuse value. So I'm going to start by drawing a triangle with a reference angle of theta. So the opposite we're saying is a distance of 7. And the hypotenuse of this long side is a distance of 8. And then we are unsure about this value down here, so we just leave it like this. So this could be this triangle. Obviously, I'm drawing this by hand. we could fix this up to make it look a little closer to being 7 and 8. Just to make it look a little more numerically correct. Okay? And then tangent, that's TOA. So opposite and adjacent. Okay? So we're going to start with P is the angle here. So P is the angle. And we are looking at the opposite side being 4 and the adjacent side being 5. And then P is the reference angle, so you could just leave it as P or you could put in a Greek letter, whatever you prefer.